Exponential functions. So with this section, we're going to be working with exponential functions, and you'll find that exponential functions, the way you go about solving, is very similar to linear functions. The only difference is you're working with an exponent, and the graph is going to be shaped as a curve rather than a straight linear line. So with an exponential function, the function is described in the pattern of f of x equals a times b raised to the x power. So this exponent here works with exponential functions. So you'll notice down below here there's a table and a graph that shows an example of an exponential function. So here we're talking about time of days and then the population of people, or any kind of population within that time of the day. So notice how with the population it's increasing, so it's multiplied by 3 each time. So 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. And notice how this graph to the right of it represents the table next to it. And this is an exponential function. And what you'll notice too is the points will connect. Whoops, not perfect, but they'll connect to create a curve. So let's just get started with some examples right away here. It says the function f of x equals 8 times 0.75 raised to the x power. This models the width of a photograph in inches after it's been reduced by 25% times. 25% x times. What is the width of the photograph after it's been reduced 3 times? Well, what you're going to do, they give you your function, 8 times 0.75 raised to the x power, and it's reduced 3 times. So what you're going to do is you're going to substitute 3 in for x. So when you do that, it's going to be f of 3 equals 8 times 0.75 raised to the 3rd power. Now when you go to solve this on the calculator, you first have to multiply 0.75 raised to the 3rd power, get that answer, and then multiply it by 8. So when you simplify this down, it's going to give you 3.375. So the width of the photograph after it's been reduced 3 times, it's going to be the size of the picture will be reduced to a width of 3.375 inches. So that's a word problem using exponential functions. Let's now get into determining when they're giving you ordered pairs, if the ordered pair is an example of an exponential function, and they also want you to explain your answer. So my recommendation is to write this ordered pair as a chart in a chart. So your x is in one column, so -1, 0, 1, and 2, and then your y is on the right column, 0, 1, 1, and 4. So notice how the x's increase by 1s. Notice there's no consistency of increase with the y's. So from 0 to 1 it's -1, 0 to 1 is 1 plus 1, and 1 to 4 is plus 3. So this situation here is not an exponential function because as the x values increase by a constant amount, the y values are not multiplied, notice not multiplied, by a constant amount. Let's look at the next example. Again, we'll set up these ordered pairs in a table. And so we have here for x's -2, -1, 0, and 1. Because if you look at the ordered pairs, my x's are -2, -1, 0, and 1. Then when I write my y values, it's 4, 2, 1, and 0.5. Notice my x's increase by 1s. Notice there is some consistency in the y's. They're multiplying by half. So 4 times half gives you 2, 2 times half is 1, 1 times half is 0.5. So this here would be an exponential function. As the x values increase by a constant amount, the y values are going to be multiplied by a constant amount. Now we're actually going to get into graphing exponential functions. So they give you a formula here, and you need to graph this. So here we have y equals 2 raised to the x power. So what I'm going to do is I'm going to create a table. Now here they're not giving you x values. You need to choose some x values. So I would recommend choosing a negative and a few positives. So here in this x I chose -1, 0, 1, and 2. What I did now then was I plugged in my values for x into the equation to solve for y. So what I did was 2 raised to the -1 power, and you get an answer of 0.5. 2 raised to the first power is going to give me 1. 2 raised to the second power, 2 raised to the -1 is 0.5. 2 raised to the 0 power is 1. 2 raised to the first power is 2. 2 raised to the second power is 4. So that's how they got their values right here. And then, after you've filled out your table, you then just graph. So here's my graph. Notice here are all my points, and they connected the points, and it creates a curve. We would call this an exponential growth too, and you'll hear that in the next section, because an exponential growth goes up. Let's look at the example B here. It says graph y equals 0.2 times 5 to the x power. Again, here we'll create a table. For my x values, I have -1, 0, 1, and 2. To get my y values, I just plug in my x values into the equation. So it's 0.2 times 5 raised to the negative first power to get 0.04. 0.2 times 5 raised to the 0 power is going to give me 0.2. So notice they're just plugging in your x to the equation to get y. Then we're going to graph this. Here's my exponential graph. Notice this exponential graph. It's not as, it's a little bit closer to the y-axis than the first one, and it's because of you're multiplying it by 0.2. So here's some examples of exponential functions and how you graph them. In our very last example, here we have y equals -6 raised to the x power. So what we do for this is, again, we're going to create a table. So I'm using, just notice I'm being consistent with my x values, -1, 0, 1, and 2. So you're plugging in these x values into the equation. So we get -0.167, -1, -6, and -36. And to graph this, here's my exponential function right here. Notice this exponential function looks a little bit different than the previous ones, but this is when you have a negative sign in front of your constant value there, these are what your exponential graphs are going to look like.